Unit 1.8, the Squeeze Theorem. Number 1. Find the limit as x approaches 0 of x squared cosine 1 over x squared. So we'll start by 1 is greater than cosine x less than 1. And then -1 is cosine 1 over x squared less than 1. And then we'll make it negative x squared less than or equal to x squared cosine 1 over x squared. So x squared. Oh, sorry. So right here we'll say the limit as x approaches 0, x squared equals 0. The limit as x approaches 0 of x squared equals 0. So we could say that the limit of x squared as x approaches 0 cosine 1 over x squared equals 0. Oh, I'm sorry. The whole thing wasn't in camera. Number 2. Let g and h be the functions defined by g of x equals negative x squared plus 2x minus 3 and h of x equals 2x plus 1. If f is a function that satisfies g of x is less than or equal to f of x is less than or equal to h of x for all x, what is the limit as x approaches 2 of f of x? So we'll take the limits of gx as x approaches 2. My mistake. G of x, and we plug it in right here. So we could say it's a negative sign. 2 squared is 4 plus 2 times 2, which is another 4, and minus 3, and these two cancel out, so this equals negative 3. Then the limit of h of x as x approaches 2, 2 times 2 is 4 plus 1 equals 5. Since these two don't match, no answer. Let g and h be the functions defined by g of x equals cosine of pi over 2x plus 2 and h of x equals x squared plus 3. If f is a function that satisfies g of x is less than or equal to f of x is less than or equal to h of x for -1 is less than or equal to x is less than or equal to 5, what is the limit as x approaches 0 of f of x? So we'll start with the limit of g of x as x approaches 0, and we'll plug it into that cosine pi over 2 multiplied by 0 plus 2 equals cosine of 0, if you remember our unit circle, is cosine of 0 is 1 plus 2 is 3, so we'll put 3 there. Now we move on to the limit of h of x as x approaches 0. Plug it into the function. 0 squared is just 0 plus 3 equals 3. So we could say, since these two match up, we could say the limit of f of x as x approaches 0 equals 3. Let f, g, and h be the functions defined by f of x equals 1 minus cosine x over 2x, g of x equals x cubed sine over 1x, and h of x equals x over sine x. For x does not equal 0, all of the following inequalities are true for x does not equal 0. State whether each inequality can be used with the squeeze theorem to find the limit of the function as x approaches 0. Start right here. We'll say the limit as x approaches 0, x squared plus 1/2, so we plug a 0 in for x, so this becomes nothing, so it's 1/2 by itself. This equals 1/2, so from that we can say no, it cannot be used with the squeeze theorem to find the limit of the function as x approaches 0. Here, limit is negative x cubed, x approaches 0, plug it into 0, 0, then the limit x cubed, x approaches 0. Since these match, yes, they can be used with the squeeze theorem. Oh, I'm not sure if I explained this. Since this is 1/2, and there's no x to plug it in on this side, so we don't even have to do this. Since 1/2 does not equal negative 1/2, that's why it cannot be used. Right here, the limit as x approaches 0, 1 minus x squared equals, again, plug in 0 becomes nothing, 1. The limit of x squared plus 1, x approaches 0 equals 1 again. So yes, this can also be used with the squeeze theorem.